Hello friends, this is Partha sir. Now today I am going to discuss a problem which is based on the transmission of heat. Recently we have seen in IIT, JEE Main as well as various other medical as well as engineering competitive examination, transmission of heat is coming very frequently. So let's see today's problem. Here it is mentioned that refer to the diagram is mentioned below. That walls of the vessel, that means these are the walls of this particular vessels, are insulated, surrounding temperature is less than -7 degree. That means this walls of the vessels are surrounding insulated, and the surrounding temperature, that means outside it is -7 degree, due to which H thickness of ice has already been formed. So this is the thickness of the ice which has already been formed. So if you just see this entire figure, this is the thickness of the ice which has already been formed, and the outside temperature which is mentioned, that is -7 degree. Now it has been mentioned, if the rate of thickness of ice at this instant is N capital N kT by 5H rho LF, where LF is the latent heat of fusion, rho is the density of ice water, and K is the thermal conductivity of ice, and A is the area of cross section. That means this is the cross sectional area of this particular ice which is formed over this particular vessels. Now what exactly they have find out? They have to find out A is the cross sectional area and then find out the value of N. So you have to find out the value of this particular N from the equation. So let's see how we can solve this particular problem. Now first, this is the diagram. Now looking into the diagram, we can say that suppose if we consider that dx dt, that is the rate, this is the rate at which the ice thickens. That means we can say the formation of this ice is taking place with respect to time. Per unit time, this is the depth of the ice which is been taking place. So now if we consider that the mass of that particular ice, so if we consider the mass of the ice which is formed or liquidate, if we consider this amount, this is suppose dm, so we can say these things that dq, the amount of heat released or amount of heat acquired. So if the ice is formed, so in that case amount of the heat released, but if the ice is melted, so in that case the amount of heat will be acquired. So it depends on the situation. So that will be L into dm, where this LF is given, that is the latent heat of fusion. So if it is latent heat of fusion, so we can say that thickness is going on, so amount of heat is released. So if it is released, so automatically the more amount of ice will be started to form. Now here this is the equation number 1. So this is equation number 1. The next stage is, we can say this equation, that equation if we elaborate, then LF and dm portion we can write down in this way. So dm is basically volume into density, that is the density of the ice, and dx, the amount of thickness has taken place. So if we consider, suppose if we consider that this is the already formation of the ice was there, and if we consider suppose this much amount of ice has formed, so this portion we can consider as a dx. So this portion we can consider as dx, that is the thickness, this is the volume of the ice, this is the area, and this entire area we can say that volume into density. So that particular portion we can write down in this form, that is dx into a, that ultimately area into length, that comes down to your volume. So a into dx, that basically the area. So sorry, this portion will be a into rho. So a into dx, that is the basically area, that is the volume multiplied by rho, that is the density, so it comes down to ultimately dm. So you have to understand this particular portion, that how it has come. So it has basically come in this form, that is volume. This portion is volume and this portion is density. So volume into density, so you are going to get the mass. So you can write down the same thing over here, that is rho into dx. So this will be your modified form of the equation number 1. Now as we know, the rate of heat transfer is dq by dt, and which is constant. So this is basically a rate of heat transfer. Now what we can do, that rate of heat transfer we can mention in the formula, that is K into A into delta T divided by that particular distance. We say we are considering it as an x distance that has been considered. So x distance thickens, the ice has been formed. So now this two equation, this is done by equation 1. So if we equate these two equations, so from equation 2 we will get, from the equation 2 we will get dq is equal to k into a into delta t divided by x into dt. So this will be our equation number 2. Now what we can do, from the equation 1 and 2, if we equate the equation 1 is equal to equation 2, so we can say LF A rho into dx is equal to k into a into delta t into dt divided by x. Now what we do here, we'll just put it in this manner, x into dx. Here we will say k into a into delta t divided by LF into a into rho. A we will strike it out, and we will integrate from 0 to h, because our thickness has already been given, and here we will integrate from 0 to t. So here k into delta t is the constant element, and LF into rho, that will become the dt 0 to t integrate. So ultimately it comes down to k into delta t by LF into rho is equal to t. So the final equation is comes down to the left hand side, that is x square by 2 is equal to 0 to h integration. This is the lower limit, this is the upper limit, which is equivalent to 0 k into delta t LF into rho into t. Now if you put this value over here, so it comes down to h square by 2 is equal to k into delta t into small t divided by LF into rho. Now what is the given in the initial first stage, it was mentioned, so that was given. So if we just put it in this manner, h by t, it comes down to k into delta t into 2 divided by LF into rho into h, and that's the final equation. That is also the rate of heat transfer, that is the rate of heat, that is not the rate of heat transfer, sorry, that is the rate of thickness of the rate of thickness of ice, and that is also given in this equation in the form of nkt divided by 5h rho into L of A. Now these two portion, one is, this is the portion, and another one is this other portion. So if we just equate these two portion, we will get n is equal to 10. So that's the answer. Thank you very much.